Hello everyone, in this video we'll be talking about the electromagnetic spectrum and atomic structure. So what's the definition of radiation? Is energy traveling through space. It can travel as waves or particles. We'll not go into details about these two. We will take it as it is. X-rays are a form of electromagnetic radiation. What do we mean by electromagnetic radiation? It's this spectrum. We can see the wavelength and the frequency, and when we change the first one, it will change the other. So what types of radiation we have? We have the ionizing radiation, for example, X-rays and gamma rays. We can see here the ionizing area where we can see the X-rays and gamma rays. And we have non-ionizing radiation, which can be radio waves, microwaves, and infrared and visible lights. Ionizing and non-ionizing means that the particle can produce ion pairs if it hits the atom. So one of the specs of electromagnetic radiation, it doesn't require a medium, and it travels at the speed of light, and it consists of isolating electric and magnetic fields. We will not go into details about these two. We just need to know that we don't need a medium to make the radiation travels through space. So let's talk about the properties of electromagnetic waves. We have the wavelength, which is measured in meter. We can measure it by meter, centimeter, millimeter, depending on that one that we measure. For example, if we want to measure the X-rays, we can measure it in nanometer, but if we want to measure the radio waves, it goes from centimeter to even meter or kilometer. So for the frequencies, the unit is cycles per second or hertz, and we can see it here in this part. Relationship between wavelength and frequency, it's inversely proportional. What do we mean by that? We mean that as wavelength decreases, frequency increases, and as frequency increases, the energy increases. What do we mean by that? When we increase the frequency, for sure the wavelength will be shorter, and for sure the energy will be high. So photon energy depends on frequency. Higher frequency means higher photon energy. Position of X-rays in the spectrum. Let's see this spectrum. The X-rays have short wavelength and high frequency. And since it has high frequency, it means that it has high energy, and therefore it's ionizing radiation. We can see here, this is the X-rays. It has very short wavelength and very high frequency, and therefore it's ionizing radiation. Therefore, X-rays have much higher energy than visible light. So let's talk about the characteristics of X-rays. X-rays interact with atoms, and it's invisible. We cannot see it. Travel in straight lines, cannot be focused by lenses, causes ionization, can be absorbed or scattered, and it produces biological effects. These are the main characteristics of X-ray. As we go through the lectures, we can see these effects, or we can deal with these effects during this course. What matter is made of atoms. You can see the matter here. It consists of many atoms. Atoms are the basic building blocks of matter. We can see it here as a building block. What about the nucleus? Nucleus contains protons and neutrons. Protons is positively charged, and neutrons has no charge. We can see it here. This is the nucleus. It has protons and neutrons. So what about the electrons? It's negatively charged, and it orbits around the nucleus. We can see it here. This is the electron orbiting around the nucleus. Now we move to a very important part in physics. It's the atomic number, or Z number, and mass number, which is A number. So for the atomic number, or Z number, it's the number of protons. So when we have element, for example, it has 6 atomic number, it means that it has 6 number of protons. It determines the element. For example, here the carbon has 6 protons, or 6 atomic number, or the atomic number is 6, and if we increase this number by 1, I mean we add just 1 proton, it will be converted from carbon to another element, which is nitrogen. Important for X-ray interactions, high Z materials absorb more X-rays. For example, bone, because it consists of calcium, absorbs more than soft tissue. So it's important to understand the Z number, or the atomic number, because when X-ray interact with that material, for sure the Z number will affect the absorption of X-rays. It creates the image contrast. So the image contrast in X-ray, or general general radiography, mainly depending on the atomic number inside that tissue. Now let's talk about the mass number, or A number. It's protons plus neutrons. So this is the total number of protons and neutrons in that element. For example, isotopes, since isotopes has the same number of atomic number, but it has different number of mass number, then this is called isotopes. Here we have an example, hydrogen with just one proton, but if we add a neutron to that proton, the mass number will be 2, but the atomic number, it will not change since we have only proton in that element, and etc. for this example. So let's see how we can read the atomic number in mass number. When we see it in the periodic table, it will be as follows. We have the atomic number above and the atomic mass below. And when we write it down, we write it as follows. This is the symbol of the element, and the mass number will be above and the atomic number will be below to that symbol. So let's talk about the electron shells. It exists in discrete energy levels. So here we have multiple energy levels around the nucleus. Inner shell electrons are tightly bound, which has high binding energy. So the difference between the K shell here, it's called K shell, and the L shell is the binding energy. When we have the electron here orbiting in K shell, it has very high binding energy. So to knock out that electron, we need a very high energy to make that electron released from that shell. And we have the outer shell electrons, which are loosely bound, which also has low binding energy. So if you have electron orbiting in this shell or N shell, it has very low binding energy, which means it will be easily knocked out from that shell. So what's binding energy? It's energy required to remove an electron from its shell. So it's higher for inner shell electrons. Here the electrons has a very high binding energy, which requires a very high photon energy to knock out that electron. Increases with atomic number. So if we have an element with a very high number of atomic number, it means its electron in the inner shell will have a very high binding energy. So what's ionization? It's removal of an electron from an atom. So when we knock out an electron from its element or from the atom, this is called ionization. Why it's called ionization? Because it creates an ion pair. What do you mean by ion pair? Pair, it means two. Ion, it means charge. So when we knock out electron, this electron will be negatively charged and free, and this element will be positively charged since we knocked out negative charge. It occurs when X-ray energy exceeds binding energy. So we need a photon with enough energy, higher than binding energy, to be able to knock out that electron. So what about excitation? Electron moves to higher energy level. It's just making the electron going from inner shell to outer shell. In this process, electron is not removed. The electron is still orbiting around the nucleus. It's a temporary state. When the electron releases that energy, it will go back to its original orbit. So what's the importance of ionization? It's the basis of biological damage. If we understand the ionization, we can understand why we have biological damage to our tissues. It's the basis of radiation detection. We know that radiation, we cannot smell it or see it. We need a tool to be able to detect if we have radiation in the area, and from ionization we can detect that radiation. And it's the basis of image formation. When we want to process the image, we need to have the basic of ionization or the concept of ionization in our minds. It causes molecular changes, and that can damage DNA, and both leads to biological effects. Either there is a direct damage to the DNA, or there is a molecular changes that will damage DNA eventually, and these two will cause biological effects or harm to the tissues. And that's it for our lecture today. I'll see you in the next lecture.